Welcome to Lesson 3.2, Factors. Today we're going to talk about how to find factors of a given number, identify composite numbers, and identify prime numbers. Okay, first, we need to know what each of these things is. So a factor is a whole number that divides a non-zero number without a remainder. So factors are numbers where when you divide, you end up with nothing left over. So for example, the factors of 6 are 1, 2, 3, and 6. Each of these numbers can divide 6 without getting a remainder. A composite number is a whole number greater than 1 with more than 2 factors. So every number has 2 factors, 1 and itself. A composite number has more than just 1 in itself. So 6 would be a good example of a composite number. It can be divided by 1, 6, and 2 and 3. A prime number is a whole number with exactly 2 factors, 1 and itself. So 6 would not be a prime number because of the fact that it has other factors besides 1 and 6. But for example, 2. 2 can only be divided by 1 and itself, so it is a prime number. Now, of course, all numbers can be divided by any number. This just means that there are no remainders. And so we're not talking about decimals, we're talking about whole numbers that can divide the numbers. Okay, and prime factorization we'll talk about later on. So I want you to take a look at it right now, though, and see if you can take a guess as to what prime factorization might mean based on what prime and factor mean. Alright, so when we factor, we're going to factor the number 12. Any number, you always start with 1. 1 is a factor of every number. When you're finding factors, it helps to find them in pairs. So I know that 1 is a factor of 12, and that 1 times 12 gives me 12. 1 times any number equals itself. So in this case, we're always going to end with the number we're factoring, because 1 times the number that we're factoring gives me 12, or whatever number we're working on finding the factors for. Basically, start with 1 and the number itself, because those are always factors of that number. Okay, your next step is to think about the numbers that are in between. Always start with the lowest number. Okay, you don't want to start with 11. In this case, it wouldn't be so bad because 11 isn't that big, but when you get to numbers like 50 and 56, that's a lot of numbers to be multiplying and dividing by, and you want to use the smaller numbers because they're going to get you to your answers more quickly, and we'll look at a little bit later why that is. Okay, so we're going to look at the next number. In this case, it's 2. This is where divisibility rules come into play. I know that 12 is divisible by 2 because it's even, so I know 2 is a factor of 12. Then I have to think, what times 2 gives me 12? That's going to be my next biggest number. So my next smallest number times my next biggest number gives me my factors. So in this case, I know that 2 times 6 gives me 12, so I know that 6 has to be my next largest factor. Okay, we keep going then, and we look at the next number. So here I have 3, so my next number would be 3, and I have to think what times 3 gives me 12. Well, I know that 3 times 4 gives me 12, so what I'm going to do here is look at if I have any more whole numbers in between 3 and 4. Since there are no whole numbers between 3 and 4, I know that I have to be done. So all of my factors for 12 are 1, 2, 3, 4, 6, and 12. Then, to make sure to show that they're factors, we put them in parentheses. If we don't put these in parentheses, it doesn't give us the indication that these are factors. Other than that, they're just a list of numbers. All right, so now we're going to look at these numbers and we are going to determine what their factors are, and then based on their factors, we are going to decide if they are prime or composite. So first let's start with 15. I always know that every number can be divided by 1 and itself. So I get 1 and 15. I look at my next biggest number. My next biggest number would be, or my next smallest number I should say, would be 2. Since 15 is odd, it's not divisible by 2. So I look at 3. 1 plus 5 is 6, so I know that 15 is divisible by 3. And I know that 3 times 5 gives me 15. So now I have to look at the numbers in between. Well, the only numbers in between 3 and 5 is 4. So in this case, I know that it would have to be 4 times itself, and I know 4 times itself is 16. So my factors of 15 are 1, 3, 5, and 15. Because I have 4 factors, I know that this number is composite. Alright, so let's use the same rules for 27. I know that I can start with 1 and 27. And then I'm going to look at the numbers in between. So my next smallest number is 2. Using my divisibility rules, I know that 2 won't work. 7 plus 2 is 9, so I know 3 will work. And I know that 3 times 9 gives me 27. So now I have to look at the numbers between 3 and 9. Well, I know 4 doesn't work. That would be my next smallest. It doesn't end in 5 or 0, so 5 doesn't work. I know that 6 doesn't work because 2 plus 7 gives me 9, so it works for 3, but since the number isn't even, it's not divisible by 2, which means that it won't work. I know 7 doesn't work, and I know 8 doesn't work just based on my multiplication facts. So what I do here is I just list my factors, 1, 3, 9, and 27, and I put them in parentheses. Again, these are composite, or 27 is composite, because it has more than 2 factors. If you'd like to, go ahead and take a minute to try 36 and 42 on your own, and you can come back and check your answers. Otherwise, we can continue to work through them together. However, I'm not going to go through each of the individual rules. I'm just going to go through the numbers and decide yes or no. So 36, again, always divisible by 1 in itself. And then I know it's divisible by 2 because it's even. And if I'm not sure, I can work it out using long division, and I know that 18 times 2 gives me 36. And now I know that I'm going to run out of room, so I'm going to make this a little bit bigger. And then now I know that it is divisible by 3 based on the rules, and I know that 3 times 12 gives me 36. And then I know that it's divisible by 4. Well, now notice I'm running out of room again. That's the beautiful thing of an eraser. Give ourselves some more room. Okay, and I know that 4 times 9 gives me 36. So 9 needs to be my next number. I know 5 doesn't work, and I know 6 times itself gives me 36. So in this case, because I have 6 multiplied by itself, that's my middle connector. So I have this part of my factor rainbow. Whenever you have that where a number connects to itself, you have to be done. I have the 4 that connects to the 9, so I can double check. 3 and 12, 2 and 18, 1 and 36. So based on the numbers I have, I know that I have all the matches that I need for factors. Now, this isn't going to mean that I always have all of my factors, because I could be missing 1, which would mean I'm actually missing 2. However, I know that for every factor that I have in here, I have its match. So at least for now, I'm doing fine. Again, this is a composite number because it has more than 2 factors. All right, and then we have 42. Draw some lines here because I know we're running out of room. So 42 I know is divisible by 1 and itself. And then because it's even, I also know that it's divisible by 2. And I know 4 divided by 2 is 2, and 1 divided by 2 is 1, so it's 21. I also know that 42, even though it doesn't look like it, is divisible by 3, because 4 plus 2 is 6, and 6 is a multiple of 3. So I have to do some division, and I have to know that 3 goes into 4 once, and then it goes into 12 4 times. So 3 times 14 gives me 42. I know it's not divisible by 4 just because I know 4 times 10 is 40. So 4 times 11 is 44. So there's no way for us to get to 42 using 4 and multiplying by a whole number. I know it's not divisible by 5, but it has to be divisible by 6. Since 2 and 3 are factors, 6 has to be a factor. So use those divisibility rules. If you have 2 and 3, then you have to have 6. And I know 6 times 7 gives me 42. Again, I'm having two numbers that are right next to each other, so I know that I have to be done. And because I have more than 2 factors, I know that this is composite. Okay, so now all we're going to do is we're going to look at the numbers in the list above, and we're just going to write down, is it prime or is it composite? Use your divisibility rules, right? So let's look at 29. 29, it's not divisible by 2, 3, 4, 5, 6, 7, 8, 9, 10, or 11, 12, 13, 14, or 15. Now the reason I stop at 15 is because 15 times 2 gives me 30. So 15 is kind of like my halfway point, because once I multiply it by 2, I get a larger number than the number that I'm working on. So in this case, I know that it has to be prime. 6, we know from our examples, has to be composite. 11, so 11 is not divisible by 2, 3, 4, 5, or 6. 6 times 2 is 12, and since that product is bigger than 11, I know that I don't have to go any further, and I know that number is prime. 13, so again, 2, 3, 4, 5, 6, and 7 do not work. 7 times 2 is 14, which is bigger than 13, so I know I'm done going through my list, and I know that 13 is prime. So basically, once I get to the point where one of my factors times 2 is larger than the number that I'm working with, I know I can just stop and determine that the number is prime. For 17, I know that 2, 3, 4, 5, 6, 7, 8, and 9 all do not work. So since none of those work, and since 9 times 2 is 18, so that's my halfway point, I know that this number has to be prime. 23, so I go through my rules. Again, 2 through 10 don't work. I know 11 times 2 is 22, so that doesn't work. And I know 12 times 2 is 24, and that doesn't work. So now that I'm above 23 with my products, I know that this has to be prime, since I don't have any other factors. So now 28. Well, 28 is even. So since it's even, that means it's divisible by 2, which automatically means it's composite. We don't even have to know all the factors. We just need to know that if the answer to the question of is it divisible by, if the answer is yes, then it has to be composite. So 27. I look at 7 plus 2 and it gives me 9. So is it divisible by 2? No. Is it divisible by 3? Yes. Since it's divisible by 3, it's automatically composite. Don't let the fact that it's odd fool you. Being odd does not automatically mean that a number is prime. The majority of odd numbers are prime, but there are quite a few odd numbers that are actually composite because of our multiples of 3, 5, and 9. 25, we know it ends in a 5, so it's divisible by 5, so it's composite. 19, so I know that 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 doesn't work, 6 doesn't work, 7 doesn't work, 8 doesn't work, 9 doesn't work, 10 doesn't work, and 10 times 2 is 20, so now we're too big, and so now I know that 19 has to be prime. Here I know that 14 is divisible by 2, so since that's a yes, it's composite. And 21 is not divisible by 2, but it is divisible by 3, so it does work. So it is composite. Again, you just need to use those divisibility rules and know your multiplication facts. Alright, so all that I'm asking you to do here is to list the factors of the following numbers and then determine if they are prime or composite. And then what I'd like you to do is I'd like you to solve the problem below that talks about Sarah putting chairs and tables together for the donators at the blood drive. You just need to let me know how many groups of chairs or how many chairs she can put in each group is a better way to say it. So I want to know if she has 24 chairs and she needs to make sure to use them all and she wants each group to have the same amount, how many could she put in each group and satisfy all of those pieces? As always, if you have any questions, be sure to write them down or email me so we can go over them in class.